We want to draw the position versus time graphs for the example that we did in 1.1. That means we're going to identify and explain the velocities as either increasing, decreasing, or constant, or zero, and then look at this to the best of our ability for the questions that we answered here, and try to put any numerical numbers that we have. Okay, so let's go look at this thing here. So the first thing that I would note right away, let me change color on this guy, is that I know that this tells me that I have a 5-meter wide patch of rough ice. In other words, that's where I'm getting the friction here. So what I want to do here is that we want to go in and try to look at this thing. So we know that the slope of this thing should tell me about the initial speed, right? So in this case here, we're talking about this guy right here being our initial speed. And then at the end, this should be our final speed right here. So we have our initial speed, and this should be our final speed. So how does this thing actually look like? Well, let's go. So if I look at the motion diagram, what I'm going to do here is that I'll draw the series of points. Let's say it looks like this. So what I'm seeing here is that I have some initial speed that looks like this. And as we talked about before, this is the start of the rough ice. And so what we know here is that we then have a patch of rough ice. And let's say that this is some distance here, and this is the rough ice. And we're going to say here that the rough ice, that what ends up happening is that there's a period of time where you're then going to slow down. And then finally, again, I'm overestimating this ice here. So I'm going to make it a little bit smaller right here and say about right there. And I'm going to say that this is where the ice ends right here. Okay. So if the ice ends here, then I'm going to say that this is my final speed right here. So I'm coming in at what? Well, I'm coming in at 8 meters per second, 8 meters per second, 8 meters per second. And all I know is at the end, I get to 6 meters per second. And I know that the distance from here to here is 5 meters. Now, what I'm going to say here is that what I'm really looking is that I'm looking at 3 intervals. There's the interval of constant velocity. This interval here is going to be constant velocity. And clearly, where the rough ice here is, I'm going to have slowing down. So the question is, how do I draw this? Well, if I look at my graph, let's try to draw this. Clearly, we have a straight line that's in red here. So I have a straight line, and that straight line, when I look at the slope of this guy here, that slope better be 8 meters per second. And at this point right here, this is the point where now this is the start of the rough ice here. So I start here with the rough ice, and then what's going to happen here is that as I go across these 3 points, I'm seeing what? A change in slope. So now I'm seeing a change in slope as I go. And so right here then represents the end of rough ice. So all of this here is that rough ice. And then what happens here is that afterwards, I then have a less steep slope. And when I look at the slope of this guy, that slope better be 6 meters per second. And so what you're seeing here is that during this whole interval from here to there, right? This whole region right in here, you're seeing what? A changing of speed. Okay, you're changing speed, but you have a constant direction. Why is it a constant direction? Look at all of the slopes are positive. So I have a constant direction since all slopes are positive. Okay, let me get the next one. And let's go do that. So I want to do the same type of thing for this other example that we did. So in this case, what we had here is that we had a reaction time and we had a braking time. So what am I seeing here? Well, in this case here, what you're seeing here is that we had, in this example, we had a constant velocity. Actually, I think I'm going to make these a little bit longer. We had a region of constant velocity. And then what happens here, at this point, you now see the object, right? You see the object. So now what you're doing here is if you see the object, this is what they call the reaction interval. And in the reaction interval, you continue to move at constant velocity until you hit the brakes here. So now, right in here, you now start the braking. And when we look at this braking here, what you're seeing here is that during the braking, we see here that these velocities are doing what? They're slowing down. And so I'm looking at this velocity here, and I'm seeing that it then goes to 2, and then it goes to 1, and then finally it goes to 0 speed. So what do I look at this guy here? Well, we typically, when we see an object, I'm going to say that this guy right here, when you see the object, this is the origin. So in other words, I'm calling that my 0 point. So when I'm looking at this thing here, what I'm seeing here is that what should happen? Well, we know that there's an initial speed of 30 meters a second, right? And we also know that the braking, the driver's reaction time is half a second. So what does this overall thing really look like when I go to plot this thing? Okay, so if I look at my plot, I have my curve. And what you're seeing here, of course, this is the origin right here. So what we want to do here is that we want to do the following thing. For starters here, note that the initial velocity is starting somewhere from back here. So if I'm looking at this point right here, we're probably talking about a point over here. So this line here is then going to go through the origin, and it continues to move at a constant velocity. So what's this constant velocity? Well, they told us that this velocity was 30 meters a second. So that right here, this is 30 meters per second, and this right here is 30 meters per second. So this whole line has to be constant. So from here to here, right? So if I look at my time, from here to here, this is the reaction time. And that reaction time has to be half a second. So now you could see here is that you have traveled some distance. This is the reaction distance. So now, after the reaction, you then have the breaking time now. So as soon as I have a breaking time, what you're seeing here is that now there is a changing of the velocity here. So now that I have a change of velocity, again, from here to here, what are you seeing? A constantly changing slope, right? I'm getting a changing of velocity here. So I get a change in speed right here. And then at some point, you then come to a stop. So at this point here, we're saying now that you've completely stopped. But if you completely stop, then that means that the slope must be flat. And flat implies, of course, that v is equal to 0, since slope is equal to 0. So again, this slope has to be 30 meters a second, right? This guy, if I look at the slope of this guy, has to be 30 meters a second, and then I end with the 0 slope line. Okay, let's get this last one. So now we have the snowboarder that glides down the 50-meter long, 15-degree hill. And what do we expect here? So to try to do this somewhat briefly, we then have what? We start at rest, and then you speed up. And then down here at the bottom, what we find here is that, God, how do I do this? I'm going to say that it suddenly changes direction here. So if I look at the speeds here, I'm going to say that this is 0.1, 2, 3, 4, 5. So what I'd expect here, as we talked about before, V4 should be less than V5. So V5 should be the steepest slope. And then you're going to travel at constant velocity, right? So if we travel at constant velocity for some distance here, then what's going to happen here is that, you know what? I'm going to change colors right here because I want to try to be as clear on this graph as possible. So this is going to be V5. So it's supposed to be longer than that. I travel at constant velocity. And then what happens here is that I'm now going to go up the hill here. So as I go up the hill, the speed should be the same length as that. And then it starts to slow down. So as it slows down, it's going to slow down very quickly and then stop. So let's see if we can go do this. So remember, this is where you reach the bottom. This is where you stop. And then of course, this is where you're moving up the incline. Okay. So once again, we start at rest, we end at rest. So how does it look like? Well, I could see that there's going to be 3 intervals. This interval right here, we're going to see that we're speeding up. This interval right here, we're going to see that we have constant velocity. And over here, we're then going to be, of course, slowing down. So that means if I have these 3 intervals, I have to have 3 intervals on my graph. So let's go look at that. Okay. So let's see how I can do this. So for starters, note that the object starts at rest. So if I look at V1, that means I have to have a 0 slope right here because it starts at rest. So now what's it going to do here? It's going to speed up. So if it speeds up, as we've already said here, we expect that the curve is going to have now intervals where I start to do what? I start to get steeper and steeper. So when I'm looking at my velocities, my slopes are getting steeper and steeper. And then I'm going to say that right here is where I reach the bottom. Well, note that at the moment that I reach the bottom, the line right here should be still at a constant slope. It should be, I should be careful. It should be steeper, right? So I said that this was V5 right here. V5 has to be steeper than here. So at this point, this guy has to be even steeper. So this represents V5. This guy over here represents V1, which is 0. Now, at this point here, we now have what? Constant velocity. So if I have constant velocity, then that means that my slope here has to be a straight line. So I move at a constant velocity, and then I'm going to get to this point here. So let's call, so if this is 6, I'm going to call this 7. So then there's 6, and then at 7, note that I'm still moving at a constant velocity at this point. So then I'm going to have another straight line. I'm going to run out of space. I got to move this down a little bit. Okay, so if I do this here, what you're seeing here, then I start to go up the hill and then I start to slow down. So as I start to slow down, I'm going to change to blue here. Then I have less steep points. And then it gets less steep until it finally goes flat. So I'm looking at my dots and I'm seeing that I'm literally going from a less steep slope. And so at this point here, this is where you're now going uphill. I mean, in real life, these curves are going to be what? They're going to be smooth, not segmented, but I'm really focusing on the slopes changes as we're going through this.
I have a question.
Sure.
Wouldn't you still need one of the like steeper green slopes, like for your first one, after you start going uphill?
Yes. You know, I agree with you. You should have, so if I was to look at this, I should have one more slope right here that then I then start to look at that, because you're right. This is 7. I think I just stopped counting points, but that's absolutely correct.